Hello everyone, this is Zahid Ghadialy. I thought I'll make another opinion piece about real 5G, and while making that it would also cover what is meant by real 4G, right, and why has this suddenly come up. It's because when operators start rolling out 5G, right, they need some kind of a differentiator. So this is one of the adverts from the UK operator 3. And what it's saying is if it's not 3, it's not real 5G, right? And just for this particular reason, they have been taken to court by another UK operator called EE. And it's not just UK, so this is actually a good example. But to have some kind of a differentiator, operators all over the world, they are using some or the other strap line, right? And it could be like in this particular case, it's if it's not 3, it's not real 5G. So why did 3 make this particular claim? So let's look at it a bit more in detail. So sometime back I actually attended one of the lectures, an extended talk by 3. Um, and this was one of the slides which was actually shared as a part of that presentation. So the point they have highlighted, and this is the point they have actually mentioned in different articles and the adverts, is basically what they're saying is, well, because 3 has 100 megahertz contiguous bandwidth, right? It's basically it sets the benchmark for 5G speeds in the UK, which is actually true, right? But this is they are doing a sort of wordplay on the IMT 2020 requirements. One of the requirements is basically the bandwidth is at least 100 megahertz, right? So let's keep this particular thing in mind that for 5G, the bandwidth is at least 100 megahertz. So, I was this is one of my favorite memes, right? And I'm which is called "This is fine." So I was just thinking about it, like whether I should say something, right, or should I get involved here or not. And then I thought, what's the worst that can happen, right? Except upsetting a few people or maybe everyone. So it's not really a new thing, right? A lot of people get upset and a lot of people agree with what I say. So I thought let's get involved. Let me put my opinion out, and people who have a problem or people who have agree with me, they can actually always add some comments to this particular video. So some of you may remember this picture which I've actually shown in some of my tutorials, right? Uh, but if you look at the bottom part, and it talks about mapping of the ITU's requirements, right, to the different generations of technology. So IMT 2000 became what we call as 3G, right? IMT Advanced is LTE Advanced, and IMT 2020 is what 3GPP calls as 5G, right? So just keep this particular thing in mind. So one of the requirements for IMT Advanced was with regards to the peak data rates. Okay, there was also a requirement for bandwidth. So what it said about bandwidth was like, well, for an IMT Advanced, it should be scalable bandwidth, but you have to have at least 40 megahertz. Okay, but the main one which I should point out is what it said is the downlink should be 1 gigabits per second, right? And of course this is the peak data rate, and the uplink should be 1 gigabits per second. So when we look at LTE, LTE has scalable bandwidth going from 1.4 megahertz to 20 megahertz. So it doesn't go to 40 megahertz. But again, the initial release 8 LTE, the maximum downlink speed was 150 Mbps, right? And the uplink speed was just 50 Mbps. So I won't worry about the latency and the peak spectral efficiency, etc. So we know just based on this that LTE was actually not 4G, right? Or it wasn't IMT advanced compliant. So what happened in release 10? is to make it compliant, the standards, 3GPP standards decided to allow aggregation of up to 5 carriers. Okay, so you have carrier aggregation that's introduced as part of release 10, and you can have 5 carriers maximum, which can be aggregated to create an aggregated data pipe. So now, if you look at the LTE release 10, you can actually meet the 40 megahertz, right? Because the release 10 is said like, okay, let's start with 2 times 20. Okay, but the downlink speeds was still 300 Mbps because you aggregate 220 megahertz, so you're just doubling what was there in release 8. But the uplink was only 100 Mbps. Now, in theory, what LTE-A said, like because you can aggregate up to 5 different carriers, right? And in theory, you can use 8 by 8 MIMO for downlink and 4 by 4 for uplink. So in theory, what the standard said is the 3GPP standards that LTE advanced standards can meet in theory the exceed the 1 gigabits per second in downlink and the 1 gigabits per second in the uplink. So this is how actually the standards make a particular technology compliant to one of those IMT or ITU requirements. And this is what I'm showing you is how 3GPP made the LTE-A as compliant to IMT-A or a 4G technology. So because of all these different well, it's not exactly a generation, but the LTE technology, some operators referred to it as 3.9G, and some said like, what, we can't be bothered, it's too much hard work, so we will call it 4G, right? If you looked at the phone, your phone icon would have still showed 4G. So even when you have the release 8 LTE, your phone icon would still be showing 4G, right? And then when it became LTE Advanced, the some of the operators who were showing 3.9G showed it as 4G now. The operators that were showing 4G, they still showed it as 4G, but in some cases they tried to put it as 4G plus because, well, it's LTE Advanced, right? And then some people referred to it as advanced 4G, and somebody even tried to change it to 4.5G. But then when the actual 4.5G or the LTE Advanced Pro came, right? Then many operators were debating what to show. Should we say this is actually a 4.9G, right? Or this is 5G, right? Or this is 5GE as AT&T is doing. So there are all these kind of debates that have happened just with the LTE. So while its LTE was introduced as part of release 8, 3GPP release 8, and of course it's still there. LTE Advanced came as part of release 10, LTE Advanced Pro came as part of release 13, and now we are 5G standards are release 15. So you have all this debate going on just for LTE, like what particular generation of technology is it. And some of the operators, like recently, when I say recently, it's mostly in 2017, they were somehow able to show in theory that their networks could do 1 gigabits uh, or roughly around 1 gigabit per second in the downlink. Okay, and they started calling this like a gigabit class LTE. But if you remember the ITU IMT advanced requirements which I showed, LTE by default is a gigabit class technology. Okay, so you had to have network which is gigabit class, right? So even though there have been this gigabit LTE networks, they are only gigabit in downlink. I have not seen a single network doing more than 300 Mbps in uplink. Okay, so I may be wrong, somebody can actually say like, look, well, our network can do, I don't know, 400 Mbps or 500 Mbps, but I'll be very, very surprised, because no network really bother to optimize the uplink, because it's like, lots of issues. The battery power consumption for the device would increase significantly, and really the devices don't need that much in the uplink, but the people who are using LTE for some kind of a broadcast, a real-time broadcast, they would not agree. They would say that they would need as much uplink speeds as they can get, but that's another discussion. So, you know, uh, even GSA released a report. I think this was in 2017 or maybe in 2018, where about gigabit LTE networks, right? Sorry, this is actually in Feb 2019. And what they said is like, well, they have identified 100 operators in 59 countries or territories, that basically showing that they have these three core features, which is carrier aggregation, 4x4 MIMO or higher, and 256 QAM modulation in the downlink. So that's how they actually achieve gigabit. And this is the theoretical speeds which you can see on the right hand side, right? The fastest networks is KDDI, Swisscom, Turkcell, that do 1.2 gigabits per second, right? China Unicom, Bell, etc., etc. But again, how do they actually reach these high speeds? So this is actually a very simple picture from one of the ARM presentations. And if you look at the center one about LTE Advanced Pro, uh, to reach gigabit LTE network, you have to have the LTE Advanced Pro, because LTE Advanced Pro extended the number of carrier aggregations from 5 to 32. And basically the reason it extended that much is so you can use the 5 gigahertz unlicensed Wi-Fi. uh, you can aggregate that along with your existing LTE carriers. So LTE carriers are licensed carriers, right? But you can use the unlicensed 5 gigahertz Wi-Fi carriers, right? So you can have a lot of 20 megahertz carriers. So what that does is, because you can aggregate so many different carriers, you can actually achieve gigabits in theory. So of course, an operator would not do so this feature is basically what we refer to is as LAA, or licensed assisted access, right? There is also an LTU, but LTU, if I'm not mistaken, is not really used by any network anymore. But the thing is, an operator would not deploy this feature throughout the country. It would only be deployed in very, very dense urban areas, right? Because of Wi-Fi spectrum, the range is limited anyway. So even though, in theory, a network can call itself a gigabit LTE network, right? But it cannot be a nationwide gigabit LTE network. So this is something to bear in mind. So here is a fact, right? So no existing 4G or LTE network, right, meets the ITU's IMT advanced requirements today. Okay, so we can always debate whether any of the networks are real 4G networks, any of the existing LTE or 4G networks. So this is an open to debate. The way it works is, in theory, as long as the standards meet the requirements of IMT Advanced, you can basically call the technology 4G, and then implementation may not necessarily meet all the requirements. So now when we jump to 5G, we have this IMT 2020 requirements, and I'm sure you have seen this particular triangle quite a few times, especially in our videos, but also any presentation which you look at which talks about 5G, you will see the requirements is uh, more than 10 Gbps peak data rates, right? 100 Mbps whenever needed. Of course, this is only for the enhanced mobile broadband or the fixed wireless access part, right? But then if you go at the to the URLLC, is less than 1 millisecond on the radio interface, or if you go to the massive machine type communication, it's 1 million devices per square kilometer. So, we can say, well, we are right now at the doing only en-gNB. So there is no requirement to meet all the, the URLLC requirements or the MMTC requirements, but, just setting the expectations like what's required from this particular flavor of 5G. So if you remember, the way 5G works is, right, we saw the IMT 2020 is what 3GPP's 5G is going to meet the IMT 2020 requirements. So there are two different types of networks or submissions which 3GPP is going to do. The first one is basically called SRIT, or Set of Radio Interface Technologies, and the set basically includes the new radio, right, or the G node B part, plus the LTE or the e-ultra part. Okay, and the submission 2 is so the submission 1 is called non-standalone, right, and the submission 2 is called the standalone, and this is only the 5G part. So if you remember, when I actually looked at the network architecture options, so the submission 1 is basically option 3, right, whereas submission 2 is option 2. But you can say that submission 1 also includes the other non-standalone options, which will basically come later. So option 4 or option 7. So now if we just talk about bandwidth specifically, so in 4G you can say the bandwidth is basically the carrier aggregated bandwidth of all the different carriers, right, which are being used to serve the 4G to a device. And the same concept applies in 5G, right? So you have carrier aggregation in 5G where you can have up to 16 different component carriers aggregated together. So the 5G non-standalone bandwidth is basically the 4G carrier aggregated bandwidth plus the 5G carrier aggregated bandwidth. Okay, whereas the 5G standalone bandwidth would be just the 5G carrier aggregated bandwidth. So this is where things become tricky. When operators roll out standalone networks, starting from next year, they would need at least 100 megahertz of spectrum, right? If you just want to meet that one particular requirement from IMT 2020, I'm sure there are lots of other requirements which the operators will probably not meet. But if you just look at the bandwidth part, it will be sort of tricky for some of the networks. Whereas for the non-standalone, things are much simpler, much easier, because if you're aggregating already, let's say around 50 or 60 megahertz of spectrum in 4G, right, you just need like another 50 or 40 in 5G. So you have the 100 megahertz bandwidth achieved. Okay, so again, this is not a very important point, but I thought let me just highlight the bandwidth aspect only. And of course, there are lots of other interesting IMT 2020 requirements, right? The peak data rate, if you talk about the peak data rate, then you need a peak data rate of 20 Gbps in the downlink and 10 Gbps in the uplink. So when I showed you the 4G, I said that the 4G's the uplink requirement was 1 Gbps, but there is absolutely no network 4G network today that can claim to be able to do 1 Gbps or not even 1 Gbps. I'll be very surprised if a network can claim they can do even 500 Mbps, right? So this is just pointing out that in theory, the 3GPP standards have to meet these requirements. In practice, no network will meet this. Again, if you look at the user experience data rate, it's probably much easier to achieve because it's only 100 Mbps, wherever you need, and in the uplink it's just 50 Mbps. But then when you come to latency, so the control plane latency is fine, it's 20 millisecond for en-gNB and URLLC. But when you go to the user plane latency, it's basically 4 millisecond for en-gNB and 1 millisecond for URLLC. So I'll be very surprised, right, with the non-standalone if a particular operator can actually achieve 4 millisecond or 1 millisecond. But even when you actually go for standalone, some of these figures like 1 millisecond and 4 millisecond will be very challenging. Okay, of course you have to remember this is only the air interface latency. So when you're talking about like a one-way latency, end-to-end one-way latency, or a round-trip latency, it would be much higher. So here is another fact, and which is no 5G network will meet the ITU IMT 2020 requirements. Okay, if you disagree, please feel free to actually leave a comment about this particular fact. So then somebody I know from the Wi-Fi industry, he said like, oh, in Wi-Fi things are so simple, right? Why are things not that simple in the cellular networks? And he basically said like, they have simplified things further, especially with all these numberings like Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. So uh, I'm assuming you probably know, but anyway, it's written on the table on the right hand side. So Wi-Fi 6 is the latest 802.11ax standard, whereas Wi-Fi 5 is the 802.11 AC and Wi-Fi 4 is 802.11n. So I thought like, just let's look at their claim, right? About, why Wi-Fi is so simple and why cellular or 5G is not that simple. So, you look at any of these Wi-Fi routers and it says like, oh, it can do a combined rate of 750 Mbps, right? So I just went and I found one on Amazon. So, but I'm sure every Wi-Fi router, it does something, and it can say something. But the thing is, just because uh, on the router can handle 750 Mbps does not mean if any device wants to basically download something or stream something, they can do it at that rate, because it all depends on the kind of backhaul you have. So if your backhaul, I've just put it as 100 Mbps, but many people have backhaul which is just like 10 Mbps or 20 Mbps. So whatever your maximum backhaul speed, you cannot exceed that speed regardless of what your router says. So if I have an 802.11n router, there is no point me upgrading it to 802.11 AC, right? Unless I'm doing a lot of things locally in the LAN, like storing things on a local server, or printing a lot of stuff. It doesn't really matter what speeds my router can do if my backhaul cannot support it. So this point is worth actually identifying, that just because Wi-Fi have got a bit simpler specs, why cellular so complex. And of course cellular does a lot more stuff than Wi-Fi, especially cellular has to do a wide area coverage, it has to do mobility management, QoS management, roaming, wherever you go, you have all these calls, right, which works from landlines to mobiles and mobiles to landlines, etc., etc. You can do all kind of inter-rat handovers between 4G to 3G to 2G, depending on the coverage and depending on the load on the network. And things like paging. So if you have an incoming call, right, network can page you, and paging is very advantageous because it allows the device to save power. It doesn't have to be listening to all the stuff all the time. So you cannot really compare Wi-Fi with 5G. So it's basically comparing a bicycle with a car. Of course, in a car you can have different kinds of cars, right? You can have just something like a Honda, you can have something like a more expensive Jaguar or Mercedes, or you can have sports cars like Ferrari. So you have different kind of cars, but basically I think comparing Wi-Fi to 5G is like comparing a bicycle to some kind of a car. So why is also 5G is also more complex? Because each country has different regulations, right? Because spectrum is not necessarily harmonized across all regions, and each country will have its own regulator. They will have their own spectrum allocation, etc. Then different operators will have different amounts and different types of spectrum. because you have the license spectrum, which is very expensive. So not all operators can actually buy a lot of spectrum. And you also have unlicensed, which you can mix, but different countries will have different rules regarding unlicensed spectrum, how they can use it, etc. And then backhaul varies from area to area. So in in a in a network in a dense areas, or in urban areas, you will have fiber, but you go to suburban, you start going to rural. Does it make sense to have fiber? Or even actually in urban, sometimes the operators use a lot of microwave, because it's very tricky to take fiber to every node, right? Especially when you have a lot of small cells around. And then some rural and remote areas rely on satellite. So they will have very high latency, but the network, even though you are using satellite backhaul, the network can still benefit from the 5G security mechanism, the QoS, etc., etc. And there are many other things, and I'm not going to go through in depth of any of these things. So but I just wanted to mention things like different slices, different functional splits, right? Network architecture options, migration paths, many other variables, because one size does not fit everyone. So each operator in each country is very different, and the standards have to be written in such a way that they can cater for all these different operators everywhere. So I thought, like, one more point I should throw in is basically the specifications. So when we had 3G, right? So in 3G, a lot of these air interface specifications. So of course we use the WCDMA for air interface, but then we had you know um, the 25 series of specifications, which clearly said that this is for 3G. Then when we went to 4G, it's basically became the 36 series, right? So everything to do with LTE is part of the 36 series. And then in 5G, you have the 38 series. So this is a good picture from Nokia, which I'm actually using here. So, if you just go to the physical layer, so, you have the 38 201 all the way till 38 215. If you go look at RRC, for example, so in 3G, RRC was 25.331, which became 36.331 in 4G, and now it's 38.331. So different generations of technology have different specifications, right? So it does not matter whether you can exactly meet all the requirements which are actually laid in IMT 2020, for example, or IMT Advanced. The implementation or the network will use specifications for a particular generation of technology, and the devices work for this particular generation of technology. So that's the good thing about standards, right? So you can go and buy a phone, and that phone says, like, it supports 5G. Then you basically check, does it support the bands which your operator supports? As long as it supports the bands, right, uh, the phone should actually work without any issues with your network. And this happens, the same thing happens in 4G as well, right? Because some of the operators, I remember, they rolled the band 28, which is the 800 megahertz, much later, and a lot of existing devices didn't support 800 megahertz. So they could not take advantage of, like, the 800 megahertz spectrum which their operator was supporting. But then when the new devices, people moved on to new devices, suddenly they found that they have coverage indoors where they didn't have coverage before. But of course they don't have the very high speeds, right? Because the 800 megahertz, generally you have 5 megahertz or 10 megahertz of bandwidth. So this is another something which we need to keep in mind. If a network is supporting 5G based on the 3GPP specifications, then it's 5G. It doesn't matter whether they are meeting all the requirements which are actually laid out in IMT 2020. So as I said, right, there will be different flavors of 5G, and each network will have something different, but again it's 5G. And any 5G device which you buy in the from in the market, that should actually work with the network as long as it supports the same bands which your network supports. So it doesn't really matter whether it meets the requirements, each and every requirement or not. So here is another fact, right? There will be different flavors of 5G, whether you like it or not. Get over it. So yeah, so this is a short opinion. It's not as short as I thought it would be, which is basically just throwing my understanding and of what 5G is. Feel free to disagree. I'm very happy for people to disagree. You disagree, you just leave a comment, right? And we can have a discussion. Whether what your understanding is or what your opinion is, and whether we can reach some kind of an agreement between us. But if you agree, I'm very happy to about that, and just leave a comment saying that you agree with me as well. So thank you very much, and see you again next time.